All right, IB AI SL2. Today we're going to talk about how to find the area under a curve. Now, there's lots of ways to do this algebraically, but in this course, we're mainly going to focus on the calculator use. So I'm going to be talking about how to do this on like a TI-84 or TI-83 type variation. If you're a Casio kid, that's fine. We just need to do some Googling about how your calculator works. So, first up, calculate this. So this integral stands for the area underneath the curve x squared plus 1. So this is the curve f of x equals x squared plus 1. And we want to find the area under the curve from 0 to 3. So if I were to shade what that integration is finding, it's all of the area underneath the curve from 0 to 3 with respect to the x-axis. Now, in the last course, or in the last class, we talked about, drawing parallelograms, trapezoids and rectangles and things like that, and triangles to try to cut it up. But because this is curved, we can't really take that approach. So here's the steps you're going to do. First, you're going to take x squared plus 1 and graph it. So you're going to hit your y equals button and then punch in x squared plus 1. Then you might sometimes have to adjust your window. I think the normal standard, like if you hit zoom and then go to zoom standard, which is number 6, that usually gives you a pretty good view of the graph, but not all the time. Sometimes you have to like show a little bit more on the y or the x or something like that. So you might have to adjust your window. Then there's this magical tool called, it's just an integration, like a definite integral button. The place you find it is in the calculate menu, which is above the trace button. So hit second, hit the trace button, which is calculate, and arrow down to the 7th one, which is that little integration symbol, f of x dx. Now the way that works is it's going to take you back to your graph and ask for a lower and an upper limit. It usually starts on 0, but if it's not there, you can just hit the 0 button. Instead of like, don't arrow left and right, just like hit the button. Yeah, so don't trace back and forth, just hit 0. Then it's going to ask for the upper limit, which is 3, because we're going all the way up to the top. And this whole thing is 12. So the area under the curve from 0 to 3 on the curve x squared plus 1 dx is equal to 12. And it even shades it on the graph for you to kind of show you what you're looking at. Next up, consider the region enclosed by negative x times x minus 3 and the x-axis. So the region that they're talking about in this problem is everything under this curve with respect to the x-axis. So that's all of this. Write down the definite integral that represents the area of A. Well, I can see that this starts at 0, but I don't know what this is right here. The way you can figure that out is by setting the curve equal to 0 and solving. So when you split these, you get negative x is equal to 0 and x minus 3 is equal to 0. So x is equal to 0 and x is equal to 3. So that means this is 3. And our definite integral is 0 to 3 of negative x minus 3 dx. Then we're going to find that area of A, where this is A. And the way we're going to do that is just on our calculator. So go ahead and punch, just like the previous problem, you're going to put negative x times x minus 3 into your calculator. And then use that second calculate integration button. And then pick your lower limit, which is 0, and your upper limit, which is 3. And when you do that, you will get 4.5. So, calculator work. Now, the last problem I'm going to talk you through, but I'm also going to show you guys in class exactly how you do these steps on a calculator because it's a little complicated using the solver for this. So the area of the region bounded by the graph x squared plus 3, and the x-axis and the vertical lines x equals -1 and a. So here's x equals -1, here's the x-axis, and then here we don't know this value of a, but we know this curve right here is the x squared plus 3 from up here. They tell us that a is greater than -1, so that just means that it's to the right of, -1, and is equal to 12. So they're telling us the area underneath the curve. It's like a work backwards problem. So here's how it's set up. It goes from -1 to a. Here's the curve that they graphed it on with respect to x, and the area is 12. Now, we don't have the algebra tools in this class to be able to solve for a right here. So what we're going to do is use the solver function on the calculator. The way you do that is you hit the solver. So solver is in the math menu, and if you scroll up, it's like the very bottom thing in the math menu when you hit the math button. Then when you hit enter on that, you can arrow up or down between like the actual equation and the where you think the answer is. I'll show you guys in class. But we essentially need to solve this. Now notice that I've taken the original equation up here and I've subtracted 12 from both sides. That's because solver only works when you're setting something equal to 0. So we're going to put this into the calculator and then subtract 12 and then tell the solver to figure out what the x value is. Now putting all of this into the calculator is kind of tricky. So here, all of this that we're trying to get it to solve, you're going to need to use this thing called fnint. Fnint is the same thing as this right here. This is fnint. You can find fnint in the math menu if you hit math and scroll up. It's like 3 above the solver. fnint has a really weird order of things. The way it goes is like this is the first thing here. You put in the function. Then you put in with respect to x. So you just put in x there. Then you put the lower limit. Actually, let's get it. I'll make it jagged. So the lower limit is here. And then, what do we do? Curly Q's? Nope, already did curly Q's. Ellipses? Yeah, we'll do like thick dots there. Yeah, this is like, it's the lower and upper limits. Now, we don't know the upper limit, so you just call it x. It's what we're solving for. What we solving? Yep, great English there, Jolly. But once you get it all there in the solver, and then, here, let me get it up on mine, then, yeah, if you arrow down to the second menu, you have to kind of put a guess in there about where you think it might be, and we know it's bigger than -1, so if you just put like 3 there, and then hit alpha and solve, and then it thinks for a while, think, and then you should get 2. But once again, I'm going to show you guys how to do this problem in class because the calculator parts are tricky. All right, you guys, good luck with your assignment today. Ask me questions.